Good morning, my dear students. Welcome to the Just Glance Academy. In this video, I am discussing some problems on work, energy and power. And at the same time, I am teaching some time skill techniques also I am teaching here so that you can manage the time and also you can solve some problems within no time or you can solve it. Okay. I will read the problem. First one. The power of a pump which raises 200 kg of water in 5 seconds to a height of 100 meter. That means M has given. M equal to how much? 200 kg M is there. Time equal to what? 5 seconds. Time equal to 5 seconds. And then height has given. Height equal to 100 meter. Now I want to calculate what is the power. Simplest problem. Power equal to what? mgh divided by what? T. Substitute all these values. Equal to 200 into what? 9.8 into height is how much? 100 divided by what? 5. Okay. In such problems, you see that I'll tell you one easiest method. Here 200. That means 2 into 10 to the power of 4 into what? 9.8 divided by what? 5. No? In such kind of problems, you make it denominator equal to 10, you make it divided by 2 and multiply by what? To here, that you can do it. So that this becomes, it becomes what? 10 that it becomes. It becomes 4 equal to 4 into what? 9.8 into 10 to the power. 10 to the power, it is 3. 10 to the power 3. So that 4 into 9.8, it comes around to 39.2 kilowatt because it is in the this one now. So that this becomes 39.2 kilowatt. So that this is the right answer. Okay. Here the detailed problem is also not required because it is both are in what somewhat confusion. There is 39.2 is there and here 3.92 is there. This is not possible. This is not possible. The probability is either C is right or D is right. But final answer is what? 39.2 kilowatt. Next. Two springs of spring constant 1000 Newton per meter and 2000 Newton per meter respectively are stretched with the same force. Whenever they use the term the stretch with the same force, the formula, just you have to modify the formula. Here W equal to, what is the formula? 1 by 2 K into what? X square. It is a standard formula. But I want to write the relation between the W, K and F because the force is what? Same, no? So that can I write it like this? 1 by 2 K square X square divided by K. But we know that F equal to what? K into X. We know this. So that W equal to F square divided by what? 2K here. Here you students, F is constant, 2 is constant. So that W is directly proportional to 1 divided by what? K here. Okay. Now ratio has given, so that W1 divided by W2 equal to K2 divided by what? K1. What is K2? 2000. This is 2000 divided by what? 1000. So that this becomes 2 by 1 or 2 is to what? 1. So that 2 is to 1. This is the right answer. Okay. Whenever the term the same force, use this formula. W equal to F square divided by what? 2K. This is the standard formula. Okay. Next. Third one. The potential energy of a system is represented in the first figure. This is the figure problem. The force acting on the system will be represented by, this is the graph of potential energy against what? Distance. Then which of the following graph is correct? Where graph is plotted the force against what? Distance here. Okay, so now we know one standard formula, F equal to minus d by dx of what? U. We know this. Or else can I write du by dx equal to minus f. We know this equation. What is du by dx? Du by dx is nothing but slope of u against x graph. U against x graph. Here you see, in this region, from this region to this region, it is slope. It is u against x. It gives from this region to OA, that is f is negative. F is negative from O to A. From OA region or in OA region, here f is negative. F is negative. F negative means which are the graph? This graph and also what? This graph. Okay. Next, in this part, from here to here, the slope equal to 0. Slope equal to 0. Therefore, when slope equal to 0 means f equal to what? 0. F equal to 0. So that the which graph is the correct, because this is the right graph. You see, from here to here, next is what? Here, and this is the what? Correct graph, because from A to B, from region A to B, there is no force here, so that and this is a wrong graph. Okay. Now the right answer is, C is the right choice. Next, a particle moves in a potential region given by u equal to, has given the value of u. Now, in terms of joules has given, its states of equilibrium will be, equilibrium means equal to what? 0. That is f equal to minus d by dx of u. U is what? 8x square minus 4x plus of what? 400. You differentiate. This f equal to minus and outside, it becomes 16x minus of what? 4. And for equilibrium, it is equal to what? 0. In the problem only has given it in the state of what? Equilibrium. Then just to modify it, it is minus 16x plus of 4 equal to 0, or else 16x equal to 4. Therefore, x equal to 4 by 16 equal to 1 by 4 equal to 0.25. X equal to 0.25. Here confusion, all are 25 is there. Carefully mark it. This is x equal to 0.25. It is the right answer. Next, fifth one. A chain is held on a frictionless table with 1/5 of its length is what? Hanging over the edge. The total length of the chain is what? L. I'll write capital L, right? Okay. Next, and its mass is m. How much work is required to pull the hanging part? This is, I'll write mgl. This is mgl. This is what? mgl. Okay, fine. Now, I'll write, this is the table. Okay. Here the chain is what? Held on it. This is the chain. Here there is hanging part is what? 1/5 part is what? Hanging. Here one should consider the mass of the hanging part you have to consider. But here there is m is the mass of the entire chain, no? But I need only the mass of this hanging part is required. I will tell you one shortcut method. In this case, here work done equal to, in such kind of problems, mgl divided by what? 2n square. This is the shortcut method, where n equal to what? 5, that is. Suppose it is 1/3 of the chain, that means n equal to what? 3. That's all that is. Now substitute here, work done equal to mgl divided by 2 into what? 5 equal to 50. This is equal to mgl divided by what? 50. This is the right answer. This is the right answer. This is the shortcut method, student. Okay, n means 1/3 part, 1/5 part, 1/6 part, that one. Okay. Next, kinetic energy of the body is decreases by 19%. Kinetic energy decreases by 19%. What is the percentage of decrease in what momentum, he is asking. Okay. The relation between the momentum and the kinetic energy, P equal to square root of 2m into what? E here. In this problem, mass is constant, only the kinetic energy is what changes here, that is. Okay. Now the second time, P1 equal to square root of 2m into. You take it as a kinetic energy equal to 1, you can take it. Here 1 minus of what? 19%. 1 minus 19 of what? E. This is this one. 1 minus 19. 1 minus 19 nothing but P1 equal to square root of 2m into what? E into 0.81. What is square root of 0.81? 0.81 square root nothing but 0.19. P1 equal to square root of 2me into what? Into 0.9. Here you have to, all answers are in terms of percentages there, no? This is P1 equal to 0.9 into P it is, because this quantity is nothing but what it is, P accord here. And then you multiply by 100, you make it here, multiply 100, so that P1 equal to 90% of P it is, 90%. The initial P equal to how much it is? 100%. So that what is the change here? 100 minus 90 equal to decreases by how much? 10%. The decrease is what? 10%. This is the answer. Suppose such kind of problems, momentum is decreases by 36%. Suppose 36, how to write? 1 minus 0.36. 1 minus 0.36 is nothing but how much? 0.64. 0.64 is nothing but what? Square root, it becomes what? 0.8. 0.8 into what? 100. It becomes how much? 80%. So the decrease is how much? 20%. These are the methods you have to adopt while solving the questions, problems in the competitive examination. That is. Okay. Next. A force F equal to 2xi plus 2j plus 3z square k Newton force has given. Okay, this is the force. Is acting on a particle. Find the work done by this force in displacing the body from 1 to 3. It is what? To what? 3, 6, 1 here. Okay. Here. Work done equal to what? Force into what? Displacement. Yes. Here there is a variable force supply. Work done equal to, in the system problems here, because I, J, K has given, no? So that it is, you write Fx into what? Dx, you write first. Next, plus integration of Fy into what? Dy plus integration of Fz into what? Dz. You write first x component, you write. This is the x component. This is equal to how much? 2x into what? Dx. Here the values changes from 1 to what? 3. The lower limit is what? X1 equal to what? 1. X2 equal to what? 3. This is the X1 equal to 1. X2 equal to what? 3. Plus next one. Y component. This is the y component. This is 2 into what? Dy. Don't write I, J, K. Next, y1. This is what? y1. This is what? y2. Here y1 equal to 2 and y2 equal to 6. Okay. Plus. Next, z component you write. Which is the z component? This is the z component. So that 3z square into what? Dz. Which is the variable here? Z1. This is what? Z2. Here Z1 equal to 3 to what? Z2 equal to 1 here. Finally, this one, W equal to 2 into, in integration, it becomes what? X square by 2. And variable is what? 1 to what? 3. Plus integration of this 2 into y square by what? 2. Lower limit is 2. Upper limit is what? 6. Plus this one 3. It is z cube by what? 3. Lower limit is what? 3. Upper limit is what? 1 here. Now this two get cancels. This two get cancels. This 3 is what? Get cancels. Now work equal to, it is work done equal to, say, x square, upper limit is 3, lower limit is what? 1, plus of y square, upper limit is 6, lower limit is 2, plus of what? Z cube, and upper limit is 1, lower limit is what? 3, that is. Now substitute all these things, it becomes W equal to x equal to 3, square means what? 9. Okay, 9 minus of what? 1, plus here y square. Oh, I made one mistake. It is not y square, it is y only. It is y only. Y only. It becomes 6 minus of what? 2, plus it is 1 minus of what? 3, that is 1 minus 3, that is no, not 3, it is cube is there, no, it becomes what? 27, that is 1 cube 1 and 3 cube equal to what? 27. Then W equal to 9 minus 1 is what? 8. Plus here I made one mistake. 2 into this quantity is cancelled here. 2 into y only. 2 into y. It is 2 into y. So that this is 2. Now it becomes 2 into 4 plus of what? Minus of what? 26. Then W equal to 8 plus of what? Plus of 8 minus of what? 26. W equal to 16 minus of 26 equal to minus 10 joules. So that this is the right choice. Here I made one mistake. Integration of dy equal to what? Y, that is. Next. A body initially at rest and sliding along a frictionless track from a height h just completes a vertical circle. It completes the vertical circle. Okay. Of diameter AB equal to d, that the height should be what? That means the moment the ball comes, you should go up. Okay. Then he's asking what is the minimum height of this student. Here at this point only what is their potential energy is there. At this point what is their kinetic energy is there here. Okay. According to law of conservation of energy, the potential energy of the ball is gradually converts into what? Kinetic energy at this point. But at this point, kinetic energy is maximum, but potential energy is what? Potential energy equal to 0 at this point. At this point, potential energy is maximum, but kinetic energy equal to what? 0 here. Student, we know that one formula in the circular motion, whenever the object is here, to reach this point, the velocity minimum velocity equal to V minimum equal to V minima equal to square root of what? Square root of 5g into r. This condition we know that. To reach the particle from this point to what? This point. We need, this is the velocity, minimum velocity is what? Required. How to solve this? Here, m g h equal to 1 by 2 m into what? At this point, va square I am writing. Here, this m is what? Get cancels. Therefore, h equal to 1 by 2 into VA square divided by what? G. Can I write like this? Okay. Here at this point the minimum velocity is there, no? V minima equal to square root of what? 5gr. Square it. Then h equal to 1 by 2 into 5gr divided by what? G, that is. Okay. Then this G is what? Get cancels. Then h equal to, what is it? 5r divided by what? 2, it is there. But in this case all answers are in what? Diameter is there, no? All are in diameter. We know that diameter equal to what? 2r. Therefore r equal to what? D divided by what? 2. Now I'll modify this. 5 divided by 2, it is D divided by what? D, equal to 5D divided by what? 10. This is the minimum height. This 2 to the 4, this becomes 5D divided by what? 4. So that this is the right choice. An interesting problem. Students. Okay. This condition you should know that whenever the object comes at this point, to reach this height, the minimum velocity, that is in the vertical motion, it should be what? 5gr, that is. Okay. Next. A man weighing 60 kilogram, the mass of the man is 60 kilogram. He climbs up a staircase using a load of what? 20 kilogram on his head. That means total mass, it becomes 60 plus of 20 equal to 80 kilogram. This is one thing. The staircase has what? 20 steps are there, but each step height is how much? 0.2 meter, like this. Like this. Each step height is how much it is? 0.2 meter. 0.2 meter. Like that, step 1, step 2, step 3, step 4, up to 20 steps are there. So the total height equal to number of steps multiplied by height. Each step height equal to 20 into 0.2 equal to 4 meter. Okay. Then G equal to what? 9.8. All are given. That time equal to how much? T equal to what? 10 second. Then what is the power? Which formula you are using? Power equal to mgh divided by what? T. Substitute this. M is 80 into what? 9.8 into what? 4 divided by time equal to what? 10. Here simplify it. It is all together. It comes around 313.6 watt. So that this is the right choice. Simple problem. Next. Which of the following is not a conservative force? Is not a. It is frictional force is not a conservative force. But magnetic force is a conservative. Electrostatic force is a conservative. Gravitational force is a conservative. That is. Only non-conservative is what? Frictional force. Students, any other examples for the non-conservative force? Viscous force. Viscous force is also comes under the category of what? Non-conservative force here. Non-conservative means it is depends on work done, depends on initial position, and it depends on the path. It depends upon the path. But for all these cases, it is independent of path. It depends only on the what? Initial position and final position here. Okay. Next. One man takes 1 minute to raise a box to a height of what? One man takes 1 minute to raise a height of what? 1 meter. Another man takes half minute to do so. The energy of the two is. Okay. Here you see, student, time is different, but he's asking about the energy. The energy of the two persons are same. Energy of the two is what? Same here. Energy is same. But times are different. That means only the power of the person 1 and power of the person 2 is different. But as if you connecting to the energy, it is same for person 1 and person 2, that is. Okay. So that this is this one here. Suppose for the same problem, if we ask for the what about power? Power of the person 1 and power of the person 2, both are what? Different here. Okay. Next. Two men with weights are in the ratio 4:3. Two men's W1 divided by W2 equal to 4/3. This is equation number 1. And the times are in the ratio of what? T1 divided by T2 equal to 12 divided by what? 11. He is asking the question, the ratio of the power. We know the formula, power equal to what? Work divided by what? Timing. Then how to write? P1 divided by P2 equal to W1 divided by W2 into what? T2 divided by what? T1. Substitute this. W1 equal to, what is W1 by W2? It is 4/3 into T1 by T2 is 12/11, but I need this one, that is reciprocal, L1 by what? 12. So that 4 1 ja, 4 3 ja, that is equal to 11 by what? 9. That means 11 is to what? 11 is to 9. So that this is the right choice. Okay. Next, 14th. Okay. A ball falls under gravity from a height 10 meter with the initial downward velocity, not free velocity. Not body is not falling freely, with some initial velocity. It collides with the ground and loses 50% of its energy in a collision and then rises to the same height. Students, read the question properly. Here, if at all an object is dropped freely, it never comes to the same height. But in this case, the object is dropped. That is what? With some velocity. If it is dropped like this. What is the height here? H. Here, initial point, what is the energy here? M G H plus 1/2 M into what? U square. Okay, fine. But as object moves down, that is what? As object moves down, the potential energy becomes 0. Only what is the kinetic energy will be there here. The kinetic energy at this point, that only the energy is 1/2 M into what? V square. Followed? At this point. Now, point is, after reaching this floor, it will rebound. It will goes back to the same height. It goes back to same height. He is saying that. Okay. It goes back to same height. Okay, fine. Now, first, after collision, its energy equal to 50% of its initial energy. Initial energy means how much? M G H plus 1/2 into what? M U square. This is the initial energy. Can I write like this here? Equal to 1/2 M G H plus 1/2 into what? M U square. With this energy, it will raise, it will go back to the what? Same height. Same height means here, can I write A ball rises. A ball rises. A ball rises to the initial height, same height or initial height. Initial height. How to write? 1 by 2 into mgh plus 1 by 2 mu square equal to mg into what? H. Here in all these problems, that is m is in this equation, m is common here. M is what? Common. Can I rewrite this equation? gh by 2 plus 1 by 2 what? U square equal to what? gh. Can I write like this? I will remodify it. 1 by 2 what? U square equal to, this factor I am bringing on the right side, gh minus gh by 2 equal to gh divided by what? 2 here. Here, this 2 is what? Get cancels. What you will get? U square equal to gh or u equal to square root of gh. Am I made any mistake? Gh by 2 of u square equal to gh by 2. Okay, here it is gh by 2. It is 1 by 4. It is 1 by 4. 1 minute. I made one mistake. Okay, I will remodify it. Gh by 2 plus u square by what? 4 equal to gh. Okay, here this term and this term simplified, then I will get u square by 4 equal to gh by what? 2. So that 1 2 get cancels here. U square by 2 equal to g into what? H, or u square equal to 2gh, or u equal to square root of 2gh. Now substitute this. U equal to square root of 2 into height. As you given the value of height, or g equal to what? 9.8. Yes, 9.8 into what is the height? It is falling from a height of how much? 10 meter. Hardly it is 10. Roughly you can consider it is 19.6 something. That is u equal to 19.6 into what? 10 equal to square root of what? 196. Square root of 196 is nothing but what? 14 meter per second. So that the right answer is this one, 14 meter per second. So this is the right answer. Okay, interesting problem. By chance, if it is not falling with some initial velocity, if its initial velocity is not given, then the body will never come back to what? Initial height. Height will go on what? Decreases in every bounce. Next. Kinetic energy of the body is increased by 4 times. Then its momentum is. Increased to. Read the sentence properly. Not increased by. Increased to. Then its momentum. P equal to square root of 2m into what? E is. Here P is directly proportional to what? E. Now that P dash is directly proportional to what? 4E, because it is increases by what? 4 times. So that P dash equal to 2 into square root of P. That means P dash equal to what? 2 into what? P. How many times increase? Doubled. Increases twice. Increases twice here. Okay. I think probably followed that is. Suppose increase by 9 times. Increase 2 is different. Increase by is different. If it is increased by means E plus 4E it becomes. Increased by. Read the sentence carefully. Okay. Next. Momentum is what? Doubled. Because it is a square root of what? E. It is square root of 4 equal to what? 2. That is. read the question. Read it. Just I'll take water. This problem is based on the what? Law of conservation of momentum and energy. A bomb of mass 30 kilogram explodes into two pieces. Okay, this is the mass 30 kilogram. 30 kilogram. It explodes into what? Two fragments. One is 18 kg and another one is what? 18, and another one is what? 12 kilogram. 18 and 12 kg. The velocity of 18 kilogram mass is what? 6 meter per second. Velocity of this one, that is how much it is? Velocity. This velocity is v equal to how much it is? 6 meter per second. Okay. Then what is the velocity of this? You have to find it. Next you have to find the what? What is the kinetic energy? You have to find it. Okay, fine. Students, initially the bomb is at rest. The bomb rest means this velocity equal to 0, so that momentum equal to what? 0. Before blasting. After blasting, what happens now is this one here, 0 equal to m1 v1 plus m2 into what? v2 here. Here you say 0 equal to m1 18. What is the velocity? It is 6 plus m2 is how much? 12 into what? v2 here. Now multiply it, this one, then 12 of what? v2 equal to minus, it is 108. Therefore v2 equal to minus 108 divided by what? 12 here it is. Here this comes around equal to velocity equal to 9 meter per second. You may ask question, what about this negative sign? The negative sign, what it represents is, if one fragment travels like this and another fragment must travel in the what? Opposite direction, that is. Then only the momentum of this and momentum of this, how they are? Equal and opposite here. Not only equal, they are in the what? Opposite direction. So that this represents here, this particle will be, if at all if it travels in this direction, this particle will be travels what? In this direction. So that velocity is known here. I want to find the kinetic energy. Kinetic energy equal to, what is the formula? Kinetic energy equal to 1 by 2 m into what? v square. Substitute 1 by 2 into, what is the mass? 12 kg into velocity is how much? 9 into what? 9. Substitute 2 1 ja, 2 6 ja. This is equal to 6 into what? 81. It is 486 joules. Is that? Yes. This problem is purely based on the law of conservation of what? Moment. And every word is important here. Initially the bomb is at what? Rest condition here. Next. The graph of kinetic energy against velocity is, this is the graph, this is the right graph. It is a parabolic graph because kinetic energy equal to what? 1 by 2 into what? m v square. Here m is constant, off is also constant, so that kinetic energy is directly proportional to what? V square. This is the formula y, and this is what? X square. Here y equal to mx square. It is an equation of what? Parabola, that is. It is symmetric with respect to this axis, so that this is the right graph. Okay. Next. 18th. A particle of mass 0.1 kilogram is subjected to a force which varies with the distance as shown in the figure. Here, figure F against what? Distance. If it starts its journey from x equal to 0, then its velocity at x equal to 12 meter. Okay, remember, word is important. Rest. Rest means at this point the initial velocity v1 equal to what? 0. That is important. Okay. This problem is based on the work energy theorem here. Work energy theorem. Here work energy theorem, we know that W equal to kinetic energy final minus kinetic energy initial. This is the formula, we know that. Okay. Of course, initial kinetic energy is 0. Initial kinetic energy equal to what? 0. My job is to calculate final kinetic energy and what? Work done. We know that area under 4 seconds displacement graph represents work done. This one looks like work done equal to 1 by 2 into what? 4. Sorry, work done equal to here W equal to, for this, 1 by 2 into 4 into what? 10. This part. Next, this part looks like what? Rectangle. It is what? Rectangle. Oh, 1 by 2. This one. Plus, it is 4 into what? 10. Plus, next, this part equal to 1 by 2 into what? 4 into what? 10 here. Now, this 2 get cancels to, this is equal to 20 plus of 40 plus of what? 20. 2 1 ja, 2 2 ja. This 4 becomes what? 80 joules. That becomes what? 80. 80 equal to 1 by 2 m into what? V2 square minus of what? 0. Why is 0? Because initial kinetic energy is 0, because at rest, particle is at what? Rest, so that V1 equal to what? 0 here. Now, this is 160 equal to mass, you substitute m into what? V2 square, substitute. Here 160 equal to mass is how much? 0.1 kg. 0.1 kg nothing but what? 1 by 10 into what? V2 square. Therefore, V2 square equal to cross multiplication, it becomes 1600. Therefore, V2 equal to square root of 1600 equal to 40 meter per second. Choice is this. Is the choice. Okay. Next. Here in this test paper I have taken the varieties of problems I have taken for the work done and all that. A mass m is moving horizontally along x-axis with velocity v collides and sticks to another mass is what? 3m. That is okay. One mass is what? M, and another mass is what? 3m. Moving vertically upward along the x-axis with velocity 2v. The final velocity of the combination is, okay. Draw the diagrams in such kind of problems. You have to draw the diagram. First mass m is, no, this is the mass m. It is moving with velocity v along what? Horizontal direction. And another mass is there. This mass is what? 3m, and it is moving along what direction? Y direction. What is the velocity here? 2v, that is. When both will be hits now, at the time after the collision, both will what? Stuck. That is what? Both bodies m and 3m what? Will be stuck here. When they are stuck now, they will travel with a common velocity v. It is common velocity v here. So that again it is based on the law of conservation of momentum. Here momentum for the first particle mv of what I cap, momentum of this, plus this one 3m into what 2v, can I write j cap, I am writing, equal to total mass 4m into what v, that is because both bodies are stuck each other, so that they will travel with a common velocity, they will travel. In all these cases m is common, this is m common, this is m common, this is m common. Can I write v of what I cap plus 3 into 2 6 of what v of what j cap equal to 4v I am writing. But is asking the final velocity of the combination, is asking, therefore v equal to then divide by this v by 4 of what I cap plus 6v divided by what 4 of what j cap, you write. Then this becomes v equal to vector symbol equal to v by 4 of what I cap plus 3 by 2 v of what j cap. This is the answer. Where is 3 by 2? I think this is the right choice. Don't cancel v here. This is the velocity along x direction. This is the velocity along what j component means along y direction here. So that this is the right choice. Which one? A is the right choice. Next. Read the problem. A particle is acted upon by force F, which varies with position x is shown in the figure. If the particle at x equal to 0 has kinetic energy 25 joules, exactly similar to the previous problem here, the initial kinetic energy equal to 25 joules. Okay. He is asking what is the kinetic energy of the particle at x equal to what? 16. He is asking final kinetic energy equal to what? He is asking. Yes, right. Again, it is the force against displacement graph. Area under the FD curve represents work done. Yes. Pause it. Pause your video and then do it. Pause your video and do it. Okay. First part from this part. Work done equal to 1 by 2 into 6 into 10. Correct? This is first part. Plus. Next, this part. It is negative side, is there? No? Negative side. Plus 4 into what? Minus 5 I am writing. Because it is minus 5. This is what? Minus 5. Okay. Next. This part again plus here 10 to what? 14. 4 into y is what? 5. Next, this part okay, this part plus of 2 into, from this is 2 and y is what? 5. It is 2 of what? Minus of 5. Yes. 2 1 ja, 2 3 ja. W equal to 30. This factor is what? Get cancels. 30. This is what? Minus 10 equal to 20 joules. Alright? 20 joules. And using work energy theorem, we know that work energy theorem, work done equal to kinetic energy final minus kinetic energy what? Initial. In substitute. What is work done here? 20 equal to kinetic energy final supposed to be calculated minus initial kinetic energy is how much? 25. Therefore kinetic energy final equal to 20 plus of what? 25 equal to 45 joules. Yes, it's the right choice. Next. A block of mass 10 kilogram is moving on x direction with a constant speed of 10 meter per second. It is subjected to a retarding force of what? Retarding force, where variable quantity is there. 0.1 into what? X. Here there is, these problems are based on the what? Variable force, not constant force. And it travels from x equal to 20 meter to what? X equal to what? 30 meter. Its final kinetic energy will be, that is, a block of mass 10 kilogram is moving on x direction with a constant speed. That means initial kinetic energy, I know that. Initial kinetic energy, we know that. What is initial kinetic energy? That is kinetic energy initial equal to 1 by 2 m into what? V1 square. This is equal to 1 by 2. What is the mass? 10 kilogram. And this is what? 100. This to 1 joule to 5 equal to 500 joules. Again, it is based on the work energy theorem here. What is the final kinetic energy is asking? That means using this data and this data, one should calculate what is the work done. That is, what is the work done. In previous problem, work done I calculated by the one is by the graphical method and another one is by the integration method. I did know. So that here first you should calculate work done equal to integration of m into what? Dx operating. It is a retarding force. Here the quantity is varying only along x direction, so that x1 equal to 20 and here x2 equal to what? 30 it is. Substitute work done equal to minus 20. This is what? 30. Substitute minus 0.1. Okay, here already have taken 0.1 into what? X unit. Minus sign just it represents what? Negative. That is what it represents, the retarding force here. That is okay. Integrate it equal to minus 0.1 into bracket of what? X into what? Dx. I forgot. It becomes x square by what? 2 it is. Here this is 20 and this is what? 30. Then work done equal to minus 0.1 divided by 2 into bracket 30 square 900 minus of what? 400, because square is there. Then work done equal to 0.1 divided by 2 into what? 500. So that to 1 joule, this is 250. 250, this one, it becomes what? 25 joules of energy. 25 joules. With minus sign, students. Don't forget, minus sign. But what is the work done? Work, according to work energy theorem, work done equal to kinetic energy final minus kinetic energy what? Initial. It is there. Substitute. What is the work done? Minus of what? 25 equal to kinetic energy final minus of what? 500. So that transfer this data so that kinetic energy final equal to kinetic energy final equal to 500 minus 25 equal to 400 and what? 75 joules. This is the answer. Okay. These are all 2-3 problems I did in this test, but where work done you have to calculate by the variable force. Work done is due to variable force. Next. 23. That is 300 joule of work is done in sliding a 2 kilogram block up an inclined plane of height is what? 10 meter. 10 meter. Draw the diagram, that is. This is the diagram. Okay. 300 joule of work is done. W equal to 300 joule. Okay. What is the mass has given? The mass equal to what? 2 kilogram. This is the 2 kilogram. Inclined plane of height 10 meter. This is the height. This is the height 10 meter. But you are shifting the object from this point to what? This point. You are shifting the object from this point to what? This point to this point. You are shifting. Okay. This is the angle theta, students. This is the angle theta. That is. Okay. Now, let's do it. Substitute this. Sin theta equal to h by what? D. Therefore, h equal to what? D into what? Sin theta. That is. Work done equal to what? mg into what? H. Okay. Work done equal to m is how much? 2. G 10. Okay. Height is how much? 10. So that work done equal to, that is equal to 200 joules. That is the 200 joules. Here you see, actually work is required is from this point to this point is 200. But the person has did how much of work done here? 300 joule of work is done. Because now you are lifting the object in this direction, that is. But frictional force is acting in what direction? Opposite direction frictional force is acting. You know? So that actually if there is no friction, this much of work is required. But because of the friction, this much of work has been done by the person. So that this is the work done by friction equal to work done due to friction equal to due to friction. Work done due to friction equal to 300 minus 200. It is, if there is no friction, this much of energy is required. But because of friction, is 300 joules of work is there. So that this difference, it gives what? 100 joules of energy due to what? Friction here. So that this is the what? Right answer. Okay. Even this theta is also not given, not required, because already has given the h has given. Suppose in the problem, if is given 20 meter, 30 meter something, in that case, theta equal to what? 30 degree. In that case, you need to calculate h by using this formula, that is. Of course, in this problem, directly has given the height, so that no need of this theta is not at all required. In some problems, he will give this value is given here, and theta value is given. By making use of these two things, you should calculate h, you have to calculate. Next, 23rd. Two similar springs P and Q have their spring constants Kp and Kq such that Kp is greater than what? Kq, that is okay. They are stretched first by the same amount. There you see, that is same amount. That means x is what? Same here. Then by the same force. Okay. There are two problems indirectly is asking. In first case 1, that is I am writing. Case 1. Okay. Next. case 2. Okay. In case 1, what is the same amount? Same amount. That means x is same. We know that W equal to half into K into what? X square. In this problem, you see, x is same. X is same here. That means W is directly proportional to what? K here. Since first spring constant is more than second spring, so that WP is greater than what? WQ. Because KP is greater than what? KQ. Clear? This is first part. Okay, fine. In second case, by the same force, just now in the previous problem I told you that same force means W equal to F square divided by what? 2K. Here F is constant, 2 is constant, so that W is directly proportional to what? 1 by what? K here. Since Kp is greater than what? Kq. Therefore, WP is less than W what? Q here. See which one? Right choice. WP greater than WQ. Okay, this is this one. Okay, and another one is WP. Okay, KP is greater, WP is less than. Thing wrong in it. WQ is greater than WP. Okay. WP. Okay, first part WP is greater than WQ. This is, and second one WQ is greater than WP. No choice are correct. Here you need to recorrect it here. This is wrong. Actually it is WP less than, I made mistake I think. Here KP is greater, so that WP is less than WQ. Okay. So that you make it corrections in this. This is not possible. This is not possible. Confusion is here. In the first part, actually WP is greater than WQ. So that this also what? Not possible. Here some corrections is required in this problem. WP less than WQ. Or we can write WQ is greater than what? WP. We can write. Okay. Next, 24th. A body of mass 3 kg is under a force which causes a displacement is given by S equal to T square by 3 meters, where T is in time. The work done by the force in 2 seconds is, okay. First acceleration you find it. S equal to T square by what? 3. Find, differentiate. ds by dt is nothing but what? Velocity equal to 1 by 3 into what? 2t, that is. Okay, fine. Next, acceleration equal to d square s upon dt square equal to 1 by 3 into 2 equal to 2 by 3. Acceleration is enough. Work done, he is asking. Work done equal to what? F into what? S. But I want to find the value of S in time what? 2 seconds. At t equal to 2 seconds, S equal to t square by what? 3 equal to 4 by 3. It is 4 by 3. That is. Now W equal to, what is this one? M into what? A into what? Yes, substitute. What is the value of mass? 3 kg. What is the acceleration? 2 by 3 into, what is the displacement? 4 by what? 3. That is, this 3 get cancels. It becomes what? 8 by 3, which is 8 by 3 joules. Okay. Next. A ball of mass m falls from a height h on a floor and its coefficient of restitution is E. The height attained by the ball after two rebounds. This problem comes under the elastic collision. That's multiple. Suppose the ball comes like this, then again go to the new height, again height. The height is gone what? Decreases, that is. Example is crazy ball. That's crazy ball. This is the what? Height h. This is the what? Height h1. This is the height what? h2. This is the height what? h3. After first bounce, second bounce, three bounce and all that. One general formula is there for such kind of problems. Hn equal to e to the power of 2n into what? Initial height. This is the formula. Remember, this is a shortcut method. Here n nothing but number of bounds. Number of bounds. Okay. Here number of bounds is how much? It is 2 rebounds. h2 equal to e to the power 2 into 2 into. What is the initial height has given? The initial height is what? h has given here. So that this h2 equal to e to the power of 4 into what? h. So that this is the right choice. Okay. It is for elastic collision. Next. Two equal masses m1 and m2 are moving along the same straight line with, remember students, two equal masses as given. Two equal masses. This is m1, m, and another one is what? Another mass is also what? m here. Equal masses. Along the same straight line with velocity 3 meter per second. So that this velocity is 3 meter per second. And this velocity is another particular velocity. This is velocity is how much it is? 5 minus 5 meter per second. Minus represents both are traveling in the what? Opposite direction here. Both will collide. Remember students, when both masses are same, when m1 and m2 are same, when m1 and m2 are same, second point is collision is elastic collision. There is a elastic plus head-on collision, that is head-on collision, that is. If these two conditions are satisfied, simply you write where the velocities are exchanged. Velocities are what? Exchanged here. So that this body m, I will call it as a A, and this I will call it as a B. Now this velocity becomes, this velocity, it becomes how much? Minus 5 meter per second. Which one? A here. And for this body, it is what? B. This velocity, it becomes how much? 3 meter per second. Just velocities are what? Exchanged. Remember this hint. That's why I told you that these are all time management tricks. It is possible only F1 and F2 are what? Same here. Masses are what? Same. That is M1 equal to what? M2. And collision is what? Elastic plus of what? Head-on collision. So that minus 5 and plus 3 meter per second. So that this is the right choice. Next. Okay. Last problem. A mass of 0.5 kilogram is moving with a speed of what? 1.5 meter per second. Mass is given. On a horizontal smooth surface, this is a ball. It will hit on this. When it hits, then certainly this will be what? Compression is produced. Yes or no? When the compression is produced, so that it is stretched, it is compressed by some length. How much it is compressed here? This is what? X, because it will hit on this. Okay. Here the formula is what? Initially when it is moving now, of m into what? V square. The kinetic energy of the ball is converted into potential energy of the spring equal to 1 by 2 k into what? X square here. So that this of this surface what? Get cancels here. Then here m equal to m into what? V square equal to k into what? X square. The maximum compression of the spring x square has cascade. Substitute m equal to how much? 0.5 into what is the velocity is given? 1.5 into what? 1.5 equal to what is the value of k? The k is 50 into what? X square here. Then simplify it. It is 5 into what? 15 into what? 15 into 10 to the power of what? Minus 3 I am writing. What? Divided by what? 50. Substitute. This is equal to what? X square equal to. Then 5 1 ja. This is what? 5 10 ja. This becomes x square becomes 15 into what? 15 into 10 to the power of what? Minus 2 becomes here. Because this 10 now, it comes, this 10 to here comes. So that x equal to square root means 15 into 10 to the power of minus 1 equal to 1.5 meter. 1.5 meter. So that this is the right choice. Okay students, now I hope that you understood all these questions, because varieties of problems are taken in this test here. Now I will end my session. Thank you one and all.